And one thing that's really interesting about instrument transformers that is different from other transformers is the accuracy. So the accuracy by which we transfer the primary to the secondary is really important, right? Because we're going to have a lower current coming out of that secondary, but we want to make sure that's directly proportional to that primary current. So we make sure we're measuring the current correctly. That's the whole purpose behind an instrument transformer. So, some of you may have seen this drawing before or understand a little bit about a current transformer, but I'll tell you a little bit about how this thing works, all right? So, essentially what you have is you have a primary conductor going through a core, all right? So you see that you've got a steel core, all right? A magnetic steel. So there's typically two different kinds of steels that are used in current transformers that we use today for metering current transformers. And they're either nanocrystalline steel or they're just an electrical steel, various grades of electrical steel, all right? And so the way this thing works is you get current going through your primary conductor, and it's going to go through that core, right? And it's going to excite a magnetic field within that core. And then you have your secondary windings around that core, right? These are copper wires around that core, and that magnetic field is going to excite an electrical field inside that secondary that is directly proportional to the primary. And how it's proportional is the amount of windings of that wrap that you have. Okay, basic stuff. Maybe you learned it a little bit in some class you might have had, but that's the way this works. And if you cut one away, this is what it looks like. So you've got your steel core in the center, and you can see you've got your copper windings wrapped around that. So the number of wraps that's how you get your ratio, okay? And we're going to talk a little bit about meter multiplier and what that is, but it's your wraps that are important. All right, so that's the way it works. You've got primary current exciting a magnetic field, it excites an electrical field, you get a secondary, and it's directly proportionate. So what we say in our industry, or in our company, it's pure freaking magic. That's how it works, right? It's magic. You get primary in, you get secondary out, and it works. And if you do it right, it should last a long time. All right, so these are going to be commercial installations. So not your typical residential, right, customer. These are going to be your commercial applications, going to be higher current, right? So that's where these are the type of customers that are going to have this on your network. And not everyone's going to have it, right? So you know, every utility is going to have a list of metered customers that need CTs. And so so not every one of your customers are going to need it, but those that need it, you'll have to have this application. So a couple of different styles that you're going to see, right, of CTs. They all function the same way I just showed you, but they're in different configurations, essentially. So one of the smaller CTs, they're used in metering cabinets, transsockets. It's not as popular, especially in the South, but it is popular in other utilities. We see it a lot in the North more, where it's a bar-type CT. So that's one style. The other one is donut. Typically called this the donut, but this is the overhead style. So this is used in overhead applications. So typically you'll see them up on a pole next to a commercial business, right? Next to, typically you'll see the pole mount transformer, then you'll see these instrument transformers, and they come down to your meter, right? So that's a very popular style in the South. Another one is pad mount, right? So again, another popular style in the South, and just about for the overhead and the pad mount are probably two most common styles you see. Every utility in the country probably has those. Those are very common. All right, now one thing special about this CT, all right? This CT needs to handle the heat, okay? So you're looking for a CT that can handle 85 degrees Celsius. Why? Because it's hot inside of a pad mount transformer, right? Especially in the South with the sun baking down on it, right? So you want to make sure that your CT can handle the heat. So one of the things you want to look at, we're going to talk a little bit about how temperature affects the accuracy of these transformers, right? You want to look for a CT that can handle the heat, especially in pad mount applications. You want to make sure you have that 85 degrees Celsius plugged in. All right, so, and then there's other ones that are different sizes and configurations, tend to be higher amperage, so if you have multiple cables, there's a lot of specialty versions. But these are a little less common. All right, and then of course primary metering, this is when you're going to be metering industrial customers. And these are very infrequent, but some utilities have these large industrial customers who are actually metering at the medium voltage level. We're not going to talk about that today. All right, so basic training. That's why I got the drill sergeant up here. I want you to be able to know 10 things about every CT nameplate. And not just my nameplate, right? I'm with AccuGrid, which is formerly Peak Demand. I founded the company 9 years ago. And so we make CTs. That's all we do, okay? And prior to that, I made CTs with another company that starts with an A and ends with a B. And there's a B in between. All right. So I've been making CTs for a long time. All right, so 10 things you should know about a CT nameplate. All right, we'll start off with the ones that are kind of most common to every CT. It's easy to understand. So instead of talking about high voltage CTs or medium voltage CTs, we're going to focus in low voltage CTs. That's the most common style that you're going to see in your utility. Secondary metering applications, commercial metering applications, that's what we're going to talk about, less than 1,000 volts. And all of our CTs, and this is when I say all of our CTs, GE, ABB, Ritz, Arteche, GEC Durham, AccuGrid, we're making 600 volt metering CTs. That's the rating that we typically talk about. When we're talking about low voltage, we're talking about 600 volts. So when you look at the nameplate, this is the way you're going to see 600 volts written. NSV 0.6 kV. Again, engineers making the simple complex. What do you think that means, NSV? Nominal system voltage, right? So that's your nominal voltage. So instead of saying voltage, we say NSV, right? And then instead of saying 600 volts, which would have been easy, we say 0.6 kV. We make the simple complex in this industry. I don't know why, but we do. I think it's because there's too many people like me who are engineers. So anyways, that's what that is. That just means 600 volts. So every single one of your CTs, secondary metering CTs, for any vendor, you're going to see NSV 0.6 kV. Everybody got it? We're almost there. You're 10% done this lecture. All right? Now, the next thing we're going to move over to here is what's called your BIL, 10 kV BIL. Anyone want to take a basic guess at what that means? I said the word basic. I gave it away. Anyone who wants to take a guess at what that is? 10 kV BIL. Yeah, lightning impulse, right? This is, your CT can take a 10,000 volt lightning strike and still stand strong. So when we're designing a CT, we'll take it to the lab, we'll strike it with 10,000 volts, and we'll see, does this still work afterwards? That's what it is. So can it take a lightning strike and still do what it's supposed to do? That's all that is. And guess what? Every 600 volt CT from every manufacturer is going to say 10 kV BIL. You don't have to worry about it. It's always the same. So simple, easy, it's on there. That's what that means. And then you're going to see this thing called FREQ. What do you think that is? Frequency, all right? And guess what? They're all going to be 60 hertz in America. So there's 3 things done. We're already a third of the way done, and you already understand everything about it. So see, I told you it was going to be easy. All right. Next thing I know, I told you there's windings on a CT, right? And the windings create that ratio between the primary and the secondary. So we have a thing called a ratio. We talk about a ratio. Now in metering CTs, we go from something to 5 amps, right? A lot of times on a protection CT, sometimes you'll see a 1 amp ratio. So like maybe 1,000 to 1, right? But when it comes to metering, you're almost always, I'm going to say always, because I mean, I've been doing this for a long time. I've rarely run into anything but a 5 amp secondary. So I'm going to say you're always going to see a 5 amp on the secondary side. So it's something to 5. So in this case, we have a 500 to 5 ratio. So if you have 500 amps going through that primary current, you're going to get 5 amps out the back, right? Make sense? It's your ratio. It's that linear relationship between your primary and your secondary. So that's pretty easy, right? And you're going to actually see it on the nameplate. It'll say ratio, 500 to 5. Now, sometimes that 500 is called the nominal current. You might hear me say the word nominal current because that's really kind of the center of the operation of that CT. So that's called the nominal current as well. And so this is the sticker you're going to see on the side of the unit. It's the ratio that's on the sticker. Some people say, oh, well, that CT can only handle 500 amps. No. That's its ratio. And it can handle a lot more than 500 amps. And we'll talk about what it can handle in a second. So what we see here on the nameplate is just the ratio. It's that direct linear proportion between primary and secondary. And you're going to see it on the sticker. And this is how we determine the meter multiplier. We divide the ratio, your primary to your secondary, we divide that together, and that's how you get the meter multiplier. So in this case, 505 CT, what's the meter multiplier? 100. Guess what? I love 505 because the math is easy, right? And so I really do encourage utilities, if you want to have fun, or if you want to make your life easier, use 505 CTs, the math is easier and you make less mistakes. That's just my advice, but anybody ever screw up a meter multiplier? It's kind of a pain, yeah. You have to say sorry a lot to the customer. All right, accuracy. This gets a little more complex when I'm trying to make it easy for you. There's only two types of accuracies that we talk about, right? We call them standard accuracy and then high accuracy extended range. I'm going to talk to you about both of them. However, if you go to our standards, which are a little bit old, dated, you'll see that there's actually 4 different accuracies that are listed in the standard for current transformers. Guess what? We don't use those 4. Nobody really does anymore. We really use this right here, the 0.3 class, which is revenue grade, right? The standard says you need to be, your accuracy, primary to secondary, has to be at least 0.3% for you to be able to meter with. Anything that's 0.6, anything that falls 0.6, they say that's indicating instrument only. That's just your instrument only. You're not supposed to be metering to that accuracy. It's not accurate enough. So the 0.3 revenue grade is your grandfather's CT. It's your father's CT. It's the CT we've been using for years and years, for decades, right? That is the technology that's been existing in this industry for a long time, right? What we have now, over the past 15 years, we've developed a new type of CT called, and it's actually better than the 4 classes that they list in the standard. It's called the high accuracy extended range. And it actually performs better than the special high accuracy rating that they have in the standard. So it's actually better than the standard. So we have 2 main products that are out there, standard accuracy CTs and high accuracy extended range. Those are the 2 technologies that exist in our industry right now. And everyone who makes CTs makes both of them, all right? And how can we make both? Because this industry is conservative and people don't like change. And so we still sell a lot of standard accuracy CTs because people don't like change. And that's okay, right? But when I sort of explain a little bit about why people have been moved to high accuracy extended range, hopefully it'll make sense to you why that people are making that move. All right, so you have these 2 classes that we use, say standard accuracy and high accuracy extended range. And when we put it on the nameplate, we put it this way. We say ACCY, that's accuracy, probably figure that out. Then we talk about the accuracy in terms of the class. So in this case, it's a 0.15S class, which is going to be your high accuracy extended range, right? We're going to put the burden right next to the accuracy, and I'm going to talk about burden in a second. But then this next line is really critical. This says that this unit is accurate from 1% of rated current to its rating factor. That's what tells you that that's actually an extended range CT, right? So this tells you it's high accuracy, 0.15S, and then the second phrase tells you that it's got this wide window. And I'll show you the window in a second so you'll understand it. Now, we always express accuracy with a burden. Does anyone want to take a guess at what a burden is? Yeah, so it's going to be the resistance on the secondary circuit, right? And what this CT is promising you with this phrase is, as long as you do not exceed 0.2 ohms on the secondary, I can guarantee you 0.15S accuracy. That's a promise, okay? So what the burden is that this is what we're promising you, this accuracy, if you do not exceed this burden on the secondary. So it comes with a promise. Now, it used to be electromechanical CT meters had a lot of burden. So burden was much more important in the past. It's less important now with today's technology. But you may have a situation where you have a very long run of wire, right, going out to a meter someplace. You need to be thinking about that, right? Because the accuracy is only reflected on the burden that it can handle, right? So again, less important than it used to be. So now you just learned something else. So the whole bottom line right here is it's telling you the accuracy it's telling you that it's an extended range, high accuracy, and that it can handle a burden of 0.2. Okay, and it might also say 0.3B 0.5. Now that's a standard accuracy CT that can handle a burden of 0.5 ohms. Does that make sense? Okay, or like we have here, 0.15S B2. So you're going to see this phrase, and you might say, what the heck does that mean? Well, now you know. You don't have to fake it. You know what it means, right? All right. Now, rating factor. So rating factor is another thing that we've made to complicate the situation. What the rating factor is simply the top end of the CT. How high can the CT perform, all right? And it is a multiplier of your rated current. So in this case, for example, you might have a rating factor of 4. And so you can see it's expressed here, RF4. Just ignore the temperature for the moment, RF4. What that's saying is I can handle, my top end is 4 times the rated current. So in this case, it's a 505, rating factor 4. It means I can go all the way up to 2,000 amps and still maintain my accuracy. So it gives you the high end. So you know how some people look at the sticker on the side of a CT and they say, oh, it can only handle 500 amps. Wrong. You got to look at rating factor. Rating factor tells you that top end. So a CT with a sticker that says 500 actually can handle 2,000 amps. Does that make sense? Because the rating factor. And you always want to look at the rating factor when you're sizing the CTs, right? Because you want to make sure they can handle it. And what this is it's saying, I can handle, me, Mr. CT, I can handle 2,000 amps of continuous current and I won't overheat. And I'll be able to perform. All right? Now, these CTs can handle spikes. Like maybe you go up to, maybe you go up to 2,500 amps for a little bit here. These CTs are going to be fine. But what it's saying, it's a continuous current. I can handle a continuous current up to 4,000 amps. And so you can see some of the math. If you have a 205 CT with a rating factor 4, your max would be 800. This is just basic math, right? So that's your continuous current. This is what you can handle. Now, we always express this in terms of a temperature. So in this case, we're saying we can do a rating factor of 4 at 85 degrees C. Why is 85 degrees C? Where have we seen that before? Why is that important? Pad mount. So pad mount. We want to make sure our pad mount CTs can handle 85 degrees C, especially those are people. We don't have everybody in the south here. I know we've got people from the north too that come to the school. But if you're in the south, you definitely want to make sure you can handle 85 degrees. So make sure your rating factor can handle it at 85 degrees. So especially on pad mount. Now, when you talk about overhead, so they'll express it in 30 degrees C or 55 degrees C. All right. And that's your judgment call, but in the north, typically 30 degrees is fine. In the south, maybe you might want to make sure you can handle 55 degrees C. Not that you're going to see that, but you want to make sure to be safe. All right, and the reason why temperature is important, because as temperature goes up, your rating factor goes down. So think about it, as your ambient temperature goes up, the CT can't handle as much heat from the current, right? So we have to derate these CTs. So, for example, if you look like this particular, 500 to 5, at 30 degrees it's 2, but at 55 degrees it's 1.5, right? So it goes down, your rating factor goes down as temperature goes up. So this is really important. So if you're sizing a CT in a particular area, right, you want to make sure they can handle whatever the temperature is that you want that it's going to handle. So, and again, in the south, if you want to make sure you're really safe, you want to make sure you can handle the 55 degrees C. Most cases, though, a lot of people use the 30 degrees C, especially in north of Virginia and north, what have you. Does that make sense? So this is your top end, and you want to make sure it can handle the heat. So you're going to get this box right here. Just tells you your rating factor. In this case, it's a 4. You can handle 2,000 amps, right? And it can do it at 85 degrees C. You want to make sure it can handle the heat. So if you're trying to size a pad mount CT and you've got, okay, so I know I won't get more than 2,000 amps, then you're good to go in this particular case. All right, there's only 4 things left. All right, you'll have your style number, which is typically your vendor part number. So this is the number that you would use to reorder that same one. So that's pretty simple, right? That's its product ID, if you will. And then it's serial number. Now, serial number is something special with current transformers. It's sort of like it's birth certificate, if you will. So it goes with that CT throughout its lifetime. So these nameplates are designed to last 40 years in the field, all right? And so you should be able to just find that serial number in the future, right, and be able to talk to the vendor and say, hey, I've got this serial number, can you give me the original test data? So, and the vendor should be able to pull out all the test data from when it was originally manufactured and how it was tested and how it was tested. And then the only other things you have is you typically have the date of manufacture, and then you'll have the standard by which it was tested, right? And then maybe some information about the vendor, right? So that's pretty much it. That's the only thing that are on these nameplates. So let's take a quick review. So if you take a look at it, there's 10 things you need to know. You need to know the style number, right? The vendor part number, the serial number, which is that birth certificate, the ratio, which is your primary to secondary relationship. We know it's 10 kVBL, lightning strike, they all do it. We know it's 600 volts here, we know it's 60 hertz. This is mom and apple pie here, they're always the same. Then we look at the rating factor, that's that top end of the CT, and then we know it's expressed in terms of temperature. And then we see that we have an accuracy of, we see 0.15S, so we know it's a high accuracy. And then we see this phrase over here, 1% of rated current to rating factor, we know it's extended range. Now, we can handle a burden of 0.2 in this particular case. And we know it was made in this year, and this is the standard. Everybody comfortable with 10 things you need to know on a CT nameplate? Okay, good. All right, the other thing you need to know is this little crazy thing right here, this expression dot to pot, and this is about polarity. You want to get your polarity right? Dot to pot means you place your dot towards your potential, your source coming in, right? So that's important. And then so you have that's your H1 side, and then you have H2 is the opposite side, and then on your secondary side you have an X1 which goes out to the meter, and then X2 completes the circuit. Every manufacturer has X1, X2, H1, H2. And dot to pot is really important. Everybody heard dot to pot before? Yeah, okay. Most important thing you need to know. All right, so I'm gonna hit the standards a little bit, but I won't bore you, I promise. So, your grandfather's CT, your father's CT. This is the way it performs, okay? This is like a flip phone. Works great, all right? Let me show you how it works. So, 100% of your rated current, so let's just say this is 100 to 5 CT, right? At 100 amps, all the way to its rating factor, and let's assume we have a rating factor of 4. So from 100 amps to 400 amps, this thing will give you 0.3% accuracy. Guess what? That is metering class accuracy. You are good to go, right? You're happy. When you're in this window, you're a happy camper. And that's what meter techs did for years, was trying to get that window right, making sure that we can handle in that window. Because what happens when we fall down below 100 amps? We start losing some of that accuracy. Accuracy starts falling. When accuracy starts falling, we are no longer in metering class. We're in indicating only. So you're not supposed to be measuring at 0.6. So a lot of times we have oversized CTs on our network, and so we're actually operating down in this region. We're not supposed to be. We need to be operating in this region. So for years and years, right, meter techs would tell me, or metering engineers, people who were speccing CTs, they wanted a low ratio and a high rating factor. Why? They were trying to make that leg, this window, as long as possible. So they'd say, give me a low ratio and a high rating factor. And so that was the common practice for years and years. But then we developed something new, which is this new technology with the high accuracy extended range. And with that, it's like a smartphone, right? It does more, right? It does the same things, right? But it can do a little bit more. And in there, we don't have to worry about this window, because we can go all the way down to 1%, down to 1 amp on the primary, we can pick that up, right? And we can pick it all the way up to the rating factor. So we have this much broader window of high accuracy. So it makes it easier for sizing your CT. You don't have to be guessing. You have this kind of a broader window. So it sort of solved a lot of problems that utilities were facing for years with this technology. So another way to look at it, your smartphone, so you said when you have 100% of your rated current, your rating factor, you're at 0.3%, you're at 0.6% below that, and below 10%, we say all bets are off. We don't know what's happening to that CT, right? The accuracy kind of gets wonky. And then on your high accuracy extended range, you have a broader window, and it's always at 0.15. Okay, and if you look at it, the way we're doing it is that steel core that we use. That nanocrystalline steel core is the reason that we're able to do that. It's able to pick up that primary current when it's much lower. And so the old technology couldn't do that. We couldn't pick it up. Anybody have a boat or been on a boat before? Do you ever notice like when you get really low on your speed, you can't steer a boat, right? So when you get too slow, you can move the rudder one way or the other. It's not going to steer. You got to have speed, right? Excuse me. You got to have speed to steer a boat, right? Same thing with a CT. You got to have current to be able to drive that accuracy. We give you some advantages to why you might want to consider high accuracy extended range CTs versus standard accuracy CTs. Number one is that you can carry less of your inventory, less SKUs. You can see here, this particular high accuracy extended range CT is 605 with a rating factor of 2. It goes from 6 amps to 1200 amps. Well, look in the past, all the different ratios you would have had to carry to be able to try to hit that same range. And one of the things you notice is that the windows are pretty small in some of these. So this is like I can't tell what that is. It got cut off. But this particular one, you've got these smaller windows. And so what's nice about having this extended range CT is it can cover all of those different ratios. So instead of having these things get all cut off, 105, 205, 405, 805, and 1005, you can have one unit that can do it all. So you can carry less SKUs, which is one big thing. The next thing is you get more revenue capture. So as you drop down into lower currents, you're still going to measure that current, right? And so you're still going to see that current. So that's a big advantage too, because sometimes when you drop down low in one of these other CTs, you're not going to pick up that load. So especially if you drop below in the gray zone, you're not going to pick up that current. So you end up getting more revenue when you use a high accuracy extended range CT, and I'll show you with just one thing. We did a field test on this to prove it. And the other thing is you have less meter multipliers, right? When you have less ratios you're carrying, you have less meter multipliers, you have less chance of a mistake. So it makes it a little bit easier on you. And again, like I said, 500 to 5 CTs are great because the math is easy. So we did a study. This was in Tennessee a long time ago. So we actually put standard accuracy CTs and high accuracy CTs into 3 different load profiles: church, large church, small church, and a ball field. We wanted to see, do we actually pick up more revenue based on this? In that particular study, we were able to pick up, depending on the load, 0.25 to 1% more revenue by using a high accuracy extended range CT. And the main reason is because you're picking up that low end. So the more variable load you have, and the more shift of loads, like you might have a load that's very high usage during the week, but very low on the weekends, or maybe the opposite if it's a church. That's when you want to make sure you have something like this that can pick up that low end. And so we've had a number of other customers have validated this, and they've actually seen more revenue pick up, but that's a good number, kind of ballpark number to use, because we've shown this to be the case. But it does depend on the load profile as to how much more revenue you'll gain. And we all know this, the meter makes the money, right? You can have all the great transmission products and distribution products and all reclosers and fancy stuff. At the end of the day, the revenue comes from the meter, right? The meter makes the money. So you want to make sure you're getting as much coming to that meter as you can to maximize your revenue. There's some products that are out there, we call them the Holy Grails, and these are the ones that can do rating factor of 4. So we have this one in our company that has, it's an overhead application. It can do a rating factor 4, which means 5 to 2,000 amps at 0.15% accuracy. We're seeing a lot of utilities saying, I just need that for overhead. I have one ratio, one CT, that's all we need for overhead. We don't need multiple ratios. So it makes their life a lot easier. So that's one of the reasons I call it Holy Grail. I chased it when I was with another company to try to get this rating. I never got it, but I was able to do it in my company now. Another one is for a pad mount. We also have a rating factor of 4 at 85 degrees Celsius. So that's a 5 to 2,000 amps, and we're seeing people standardize on this one and maybe have a 2,000 to 5 for the high end. So only 2 ratios, and it can handle all your underground applications, all your pad mount applications. So we're seeing a lot of people reduce the number of SKUs they cover or they carry by using these in an effective way. And it makes your life a lot easier when you use these applications. All right, thanks for your attention, and enjoy your lunch. Take care.